Hello, this is Nikki Jackson, one of the adjunct instructors for Concord Career College. And what you see on the screen right now is several examples from Homework 8 from Math 1320. So hopefully you'll be able to zoom in on your computer so we can discuss number 1 and number 2. In summary, all of Homework 8 is pertaining to quadratic equations. So it's going to be a lot of zooming in and zooming out at this time. So right here I'm going to zoom in, and you can see that the quadratic equation itself is x squared minus 6x minus 72, and your answer is negative 6 and 12. So what I'm going to do now is change out the slide per se and show you how I work this out. So once again, my apologies, it's going to be quite a bit of zooming in and zooming out. So given to you again, you have the equation x squared minus 6x minus 72 equals 0. What I did was break up this trinomial, which has 3 terms, 1, 2, 3, into a binomial, which has 2 terms. So you got your 2 x's, so here's your x, there's your x. And then we have to figure out what can give us a product of 72, but a middle term of 6. So over here, I wrote out all the factors, aka multiplication, of 72. So 172, 2 times 36, 3 times 24, 4 times 18, and 6 and 12. Notice how there's a dot right here for 6 and 12, because if I added or subtracted these two, I'm looking for something that gave me the 6. So this pair of numbers was the only one that gave me the 6. So you can see the others that gave me 71, 73. I didn't have one right here, so my fault. And then 36 plus 2 is 38, subtract 2 is 34, on and on. So I got the 6. So for this pair, I wrote out the 6, and then I wrote out the 12 right here. But notice how that middle term right here is minus. Hence, your larger of that pair, which is the 12, is going to be minus, and that 6 has to be positive. The reason being, let's go back over here now. If you multiply two negatives, they're going to give you a positive. But that last term is negative. Multiply two positive, they give you a positive. Again, that last term is negative. So we know that we have to have two unlike terms. So one had to be negative, the other one had to be positive, because that last term was negative. And that middle term, since it was negative, that sign went with the larger number. Now we're going to factor. Well, that's what we just did. Now we're going to let each binomial equal 0. So subtract 6 from both sides for this one, you got negative 6. Add 12 to both sides for this one, you got positive 12. So your solution set, or your answer, is going to be 6 and negative 12. So again, it's a lot of back and forth, so my apologies. I'm going to zoom in again. Your next quadratic equation is n squared minus 28 equals 0. So notice how your answers have these radicals. Be mindful, radicals are the same way of saying square roots, and you can have them either negative or positive. So let's figure out how they did that. So I'm going back, zooming out. So the first thing I did was rewrite it, and after I had rewritten it, I'm going to add 28 to both sides, because I'm trying to cancel it out. Now I'm left with n squared. To cancel out anything squared, we're going to take the square root. And remember, square roots are going to be both positive and negative. Well, this is not a perfect square, meaning that I don't give just one number. So I'm factor 28. And the first thing that pops in my mind with multiplication is 4 and 7. Of course, you can do 2 and 12. I'm sorry, 2 and 14 as well. But let's try to deal with single digit numbers if possible. I'm going to break it down even further, so I'm still going to have the plus and minus. Square root of 4 times square root of 7. Well, just so happens the square root of 4 is 2. There is no square root of 7 because 7 is a prime number. So rewrite it yet again, plus and minus square root of 2. Bring down the radical 7. So your final answer is going to be both positive square root of 7 and negative square root of 7. So when you rewrite it or type it in a calculator, I'm sorry, not calculator, computer, write it as an ordered pair, so your negative will come first. Once again, it's a lot of zooming in and out so you can actually see the problems. Here's another quadratic equation, but notice how your answer, which is in the little box, is pertaining to an I. So you may recall way back on the first day of class when we were doing module 1, you had real numbers and imaginary numbers. Well, the I represents your imaginary numbers. So let's figure out how to do that one. So let me zoom out. Trying to make sure you see everything. Alright, awesome. So this step right here, I rewrote it. But now I'm going to do something called completing the square. So I'm going to take half of that 18. Half of 18 is 9. Then I'm going to 9 squared. That's the square part. 9 times 9 is 81. So I added 81 to both sides of this equation. Negative 82 plus positive 81 is negative 1. But this right here on the left hand side, I can factor that trinomial into a binomial. So that binomial now is y minus 9 and y minus 9. Because it's 2 of them, that's why it's squared. Here's a little hint. 81 is a perfect square, which is 9. And then 9 plus 9 is 18. So that's how I knew it was going to be y minus 9 squared. To eliminate the square, we're going to take the square root of negative 1. So we got y minus 9 plus or minus square root of negative 1. Negative 1 does not exist under a radical. So we're going to rewrite that and call that I. So here's just a fun fact right here. I is negative square root of negative 1. I squared is negative 1. I cubed is negative I. And I to the 4th power is positive 1. Main thing you need to remember is that I squared equals negative 1. So go back over here to the I. If we're trying to get the y isolated, we're going to have to add 9 to both sides. So if I add 9 to both sides, I can get negative I plus 9, or I can get positive I plus 9. They're both the same thing, so be careful when you write that. So let me just rewrite it over here. So you got negative I plus 9, and then you can have positive I plus 9. They're the same thing. Just think about if you ever stand in the mirror, how your numbers may flip. Once again, a lot of back and forth. So let's zoom in on number 4. Notice how your first term is negative. And look at your answers. Your answers also have those positives and negatives in there. So this is going to be quite a bit. Also, if you read it, now you're using the quadratic formula. So let's jump out for a moment to figure out how to do that one. Okay, so here's the actual equation right here that was given to you on the paper. You had negative y squared plus 7y equals 7. I subtracted 7 from both sides to make one side equal 0. Now, this part in the green, which I hope you can see, is the quadratic formula. So you have negative b plus or minus the square root of b squared minus 4a, all divided by 2a. So we're going to substitute our values in where b is 7, a is negative 1 because you have negative 1y right here, and then c is negative 7 because you have your negative 7 right there. I substituted all my values in, so hopefully you can see that. If I'm going too fast, please pause. So we have negative 7 plus or minus square root. 7 times 7 is 49. Negative 4 times negative 1 is positive 4. Positive 4 times negative 7 is 28. 2 times negative 1 is negative 2. So that's where that came from. Jump down. 49 minus 28 gives you the square root of 21. Bring everything else down. 21 is not a perfect square. So notice again, radicals have both positive and negatives. So when you write your answer out, it's going to be 7 minus square root of 2. I'm sorry, square root of 21 over 2, comma, 7 plus square root of 21 over 2. Now we have this one. So I'm going to zoom in. Take a moment to read it now. because now it's asking you to use the discriminant for 35x squared plus 18x minus 5 equals 0. Your answers are going to be in fraction form. So let's figure out how they got those answers. So by definition, discriminant is very relevant to the quadratic formula itself. In fact, it's everything that was actually in the square root. So its discriminant is b squared minus 4ac. To determine what type of solutions you're going to have, if your answer or your discriminant is less than 0, there are going to be 2 non-real answers. If it's equals 0, it's 1 real solution. And if it's greater than 0, it's 2 real solutions. So given your equation, we can identify what A, B, and C are. So I'm going to substitute A, B, and C into the discriminant itself. So that's 18 squared minus 35 times negative 5. I can simplify all of that. So 18 squared is 324. Once I multiply all that, that's 700. So now my answer is 1024. So since it's greater than 0, we know that it's going to be 2 real solutions. Using the quadratic formula now, we're going to determine what those solutions are. So once again, substitute my values in. So A, B, and C. So take a moment to actually pause and figure that out if I'm going too fast. Once I have substituted all of my values in, jump down here. The square root of 1024 is a perfect square. It is 32. So your final answers are going to be negative 18 plus 32 over 70. Then you can say negative 18 minus 32 over 70, which I can simplify even further. So for this one, that's going to give me, what is that? 14 over 70. I can simplify 14 over 70 by dividing both sides by 14. That's my 1/5. This one, negative 18 minus 32 gives me negative 50 over 7. Divide both of those by 10. So my answer is negative 5 over 7. So again, your final answers are negative 5/7. Then the next one is 1/5. Once again, we're going to zoom in and to solve the equation. Notice how you have 4 answers for this one, so it's quite a lot. So we got negative 2 over 3, positive 2 over 3, negative I squared root of 5, and positive I squared root of 5. Notice how this one also is, the first term is x to the 4th power. So let's figure out what's going on right there. So hopefully you can understand my penmanship. It is not the best. So the actual equation is 9x4 plus 41x squared minus 20 equals 0. So let's try to simplify this. We're going to let x equals x squared. So what we're going to do, every time we see an x squared, we're going to replace it with x to make it a little bit easier. So now that x squared is now x, and that x to the 4th is just x squared. So again, every time we see an x, replace it with x squared. Rewrite it, we have 9x squared plus 41x minus 20 equals 0. Using the AC method, we're going to use grouping. So 9 times 20 is 180. What factors of 180 can give me a sum of 41? So I listed them all down right here. So 1 times 180, 2 times 90, 3 times 60, 4 times 45, 5 times 36. It could be some more, but I stopped because we still can do 10 times 18. And again, the reason why I stopped, that one right there gives me 41. Because 45 minus 4 gives you 41. I grouped them using that same pair. So I have to look at it carefully. So 45 and 4. Well, 9 and 45 can go together because they can both factors. And then the 4 and 20 can go together. Now that I've done that, I factored out the 9x, leaves me with x plus 4. Right here, factor out negative 4, leaves me with the x plus 5. I said x plus 4 earlier, so my fault. Both of them have the x plus 5, and notice on the outside of the parentheses, you got x minus 4. Now I'm going to take each one of these binomials and let them equal 0. So 9x minus 4 equals 0. So add 4 to both sides and then divide by 9. X is 4 ninths. For this one, x plus 5 equals 0. Subtract 5 by both sides. You're left with negative 5. So your final answer is going to be not final. Your x equals 4 ninths and negative 5. Here's why it's not your final answer. Remember up here, we said x was x squared. Well, now we got to determine what the x squared is. So going back, x squared was 4 ninths and x squared was negative 5. Well, the opposite of something being squared is going to be the square root. So we're going to take the square root for each one of these. Break this down. The square root of 4 is 2. Square root of 9 is 3. Remember, they can be both positive. So over here we got negative 2/3 and positive 2/3. Over here we got negative 5. Remember, we can't have a negative on that radical, so that's where the I is factored out. So we have negative I square root of 5 and positive I square root of 5. So don't forget, a negative cannot be under the radical. Here's number 7. Notice this is a compound inequality. Keyword inequality means that you're going to have to graph it. The other thing you should recognize is that here's an inequality sign. Because it's an inequality sign, we know that we're going to have to use bracket because it has half that equal sign right there. So let's figure out how to do this. So again, my apologies for going back and forth. Back and forth. Aaliyah popped in my head, y'all. Okay, so here's your inequality. 2x minus 1 times 6x plus 7 is greater than or equal to 0. Where for each one, right here, we're going to solve for x. So for this particular one right here, again, pause the video. You got x equals 1/2. But for this one, be careful with it. Because it is negative, it is no longer x greater than. It's going to be x greater than or equal to negative 6. Whenever they're negatives, you're going to have to flip the signs. So for right here, it's just going to be x greater than 1/2. So this is taught in another, or should have been learned or taught in a previous example from module, I'm not really sure what module, but I know it's before module 8. So here we go. So again, pause if you don't understand how to solve for x for each one of these. But remember, it flipped right here because it was a negative. Well, now that I have that, and we read our number lines from left to right, negative 7 is going to be right here, or negative 7/6. Because you have that equal sign, that's why you have a bracket. And notice the direction that it's shading in. So it's shading to the left. Because it keeps going and going and going and going, that's why you have the negative infinity and then negative 7, negative 7/6. Because it's a compound inequality, that's what the union stands for. It's almost like the word and. We're going to do the same thing. Have a bracket 1/2, and then notice how it's shading here. On and on to positive infinity. So in case you have forgotten, you got that, which is less than. Less thans are going to be using parentheses, and you're going to be shading to the left. Then we have less than or equal to's. You're going to be using brackets for those. And you're going to always shade in the direction in which you see it. That means for the greater thans, and this is just a quick refresher, you're still going to use parentheses, shade to the right now, but if it's greater than or equal to, and my penmanship is not the best, still going to shade right. So if it's a less than or less than or equal to, you're going to shade left, greater than or greater than into shade right. Include the brackets when it has half of the equal sign. So that was just a quick refresher. Your next one is pertaining to a function. So what it's asking for is state whether the ordered pairs represent a function. And you see how it says yes. So what I'm going to do now is break it down so you can actually see it. Here's the reason why it says yes. So I wrote all 4 ordered pairs. So 1, 2, 3, 4. I split them as your x coordinates and your y coordinates. Notice how there's a pattern to your x's and y's. So in this particular case, my pattern is that I'm multiplying by 2. But if I couldn't identify the pattern, that's one way. The other thing is that notice how your x values are not repeating themselves. So first step, if you can identify a pattern, that means that it is a yes. The second step, if the x values do not repeat, notice how I said no x value repeats, that's also justification of why it is a yes. So in this case, it is a function. Your next one. Determine whether the indicated graph represents a function of x. Well, yes, I know that it represents a function of x, because it just so happens I know about parabolas. So for this particular example, the function is y equals x squared. No, you're not supposed to know that. But what you are supposed to know, that it passes the vertical line test. So if you didn't know this period, like, just no, you didn't know it. But you see the picture. Imagine if you're doing the vertical line going up and down, going across the x-axis. So my pencil is just going across. Or I can just visualize it. Notice how none of the x values repeat themselves. So in other words, when I'm looking at this, if it was on a grid, none of the x values repeat. Because no x value repeats, that makes it a function. Moving on. Here's an example of a function, aka an equation, where you have to use substitution. It wants you to substitute 14 over 3, 9, and negative 1 over 3 into the equation of square root 3x plus 2. So a function is just like an equation. Well, let's see what's going on right there. So again, I'm going to do not a lot of it, but quite a bit. We're zooming in and out and changing papers, because I tried to work out the problems before I presented them. So here's your actual function, aka equation, square root of 3x plus 2. So for the first substitution, I substituted 14 over 3. The 3's cancel each other out, so now I'm left with 14 plus 2. 14 plus 2 gives you 16. The square root of 16 is 4. The second substitution was 9. So 3 times 9 is 27. 27 plus 2 is 29. I can't factor or substitute anything else, so hence your answer is square root of 29. And your last one, you substituted negative 1/3. The 3's cancel each other out, so now I'm left with negative 1 plus 2. Negative 1 plus 2 is 1. Square root of 1 is 1. So ta-da! Your next example is still pertaining to a function, but it's always those beloved word problems that we just dread. So I'm trying to get it situated where you can still read it and figure out how I got the numbers that I got. And if you read this carefully, the function is, which is what it's asking for, is an equation, and it gave you the answer. So this would be the ideal time to actually pause the video so you could read it, because now I'm about to show you what I did to get the answer. So everything that was given to you right now was in the reading. So we let our x values represent the mileage, and we let our y values represent the monetary amount. Now the reason why we did that, we were just reading it carefully, and it's saying, if you did it, it says let x be your miles and let x of x be in your dollars. So that's the same thing saying x in miles and y be your money. So that's why I wrote it out like that. So you have to read it carefully. Using the slope formula, which is y2 minus y1 over x2 minus x1, I determined what my slope was, so my slope is 720. Now using the point slope formula, which is this right here, I substitute the values for my slope and point 1 into this equation. Simplifying everything, so I use the distributive property on this end. So 7 times, 20 can go into 222, 11 times 7 is 77. And I got the 77 by multiplying. Then I added 107 to 77. I got 30. Using your calculator, 7 divided by 20 just so happens to be 0.35x and 30. So that is your equation. Your next one, you're going to have to play around with that one on your computer to figure out how to actually use the parabola tool. And this should have been introduced to you when we first logged into Cengage. Well, the easiest way to identify this is to figure out what our vertex is. That means that little part right here. So if it was upside down, that would be like your mountaintop, and since it's down here, we're going to call it like a valley. So let me zoom back out yet again. So the actual equation itself is x squared plus 4x plus 7. We're going to get that 7 on the opposite side because there's no x to it. Now I'm going to complete my square. You may recall this from module 6. So half of 4 is 2. 2 times 2 is 4. If I add it on one side, I have to add it on the other. This trinomial can be broken down into a binomial, which just so happens to be x plus 2 squared. Negative 7 plus 4 is negative 3. So now I'm going to rewrite it again and bring the 3 over. Here's your formula for a parabola. X minus k squared plus h, where k and h are your vertex. Notice how it's a negative right here, but it's a positive right there. 2 negatives give you a positive, so my vertex is at negative 2. And then my y coordinate is at positive 3. So again, you have to play around with the graphing tool to figure that out on your own. Here's your next equation. So let me zoom back out, or zoom in this case. It wants to know what your x-intercepts and y-intercepts are. Well, I know I'm going to have 2 of them because, look at the degree. Your degree is your highest exponents, so I know I'm going to have 2 x-intercepts. Plus, I know it's going to be a parabola because of the x squared. So let's figure out what our intercepts are. So here's your actual function, aka the equation, x squared minus 16x plus 63. I'm going to factor it to make it a little bit easier. So looking at the 63, what are the factors of 63? So I got 1 and 63, 3 and 21, 7 and 9. Now that I have those pairs, which one of these pairs gives you 16? So it's going to be 7 and 9. So that's what I did right here. I add and subtract them, and I gave me 16. Split your trinomial into a binomial, or 2 binomials. So you got your x's, you got your 7 and 9, but that gives you 63. But pay attention to the signs. Because you got a positive right here. Remember, 2 negatives give you a positive, and that middle term just so happens to be negative as well. Both of these are going to be negative. Now that I have this, I'm going to solve for x for each term, or each binomial in this case. Add 7 to both sides, x is 7. Add 9 to both sides, you're going to have 9. Still dealing with functions. Here we go. Take out your wonderful handy dandy calculator, because this requires a bunch of graphing. So I'm going to show you how to do this. So let me zoom in. Here's the actual equation itself. So once I cut my calculator on, I'm going to hit the Y equal key. Different people got different versions of the calculator, so yours may not look just like mine, but we're going to type it in very similar. So open parentheses, so hopefully you saw my finger right here, minus 3, close parentheses. hit your exponent key again, look at my finger, then we're going to have 3. Depending on what version of your calculator it is, pay close attention to it. If you have an arrow, that's the right arrow, hit the right arrow. Now we're going to have -2. Hit enter. So if you lost, or anyway, some form of fashion, make sure that you did it right. Like I did not do it right. So I got to do it. Open parentheses. Here goes your X where my finger is. -3. Close parentheses. Exponent key 3. Hit your right arrow. -2. Hit enter. In the upper right hand corner, you're going to find zoom. And I said right hand corner. It's somewhere in the middle. Zoom. Go down to zoom standard. Hit enter. It graphed for you. Well, it kind of looks like that one. So we can eliminate this one. And we can eliminate this one. Because notice how it's on that side. So let's go back to the calculator now. Which one is it going to be? Well, let's look at our humps now. Pay close attention. Can't be that because that one's above the x-axis. Can't be this one because it's over here in the wrong quadrant. Can't be this one because again it's in the wrong quadrant. So what is left is this one. So notice how it's also have an x-intercept of 4. That one is a 2. Still pertaining to your graphs. Let's do another one. You're going to get very comfortable with your calculators. So now we're dealing with absolute values. And I know they're absolute values because I see the little V part. So we're going to zoom in. There's the actual equation. So once I cut my calculator on, I have to zoom in and out so I can see everything. So I'm going to go to at the y equal, hit clear. To find absolute value, meaning those 2 brackets right there, I'm going to hit my math key. And I'm looking for it too. Where is it, y'all? There we go. I found it. So let me retrace my steps. Hit the math key, or y equal, math key, use your right arrow key, go to number. ABS stands for absolute value, so you're going to hit enter. Notice how you have your brackets. Depending on how old your calculator is, you might have parentheses. So we're going to hit X plus 4. Use your right arrow key now to get out of those brackets. And now we're going to hit -1, enter. Go back to zoom, go to zoom standard. Here we are with our graph. So you got to pay close attention to where the graph is located. So I can eliminate these 2. Because notice how those are on the right hand side of the y-axis. This is on the left hand side. So now I'm looking at these 2. I can eliminate that one because this one has a x-intercept. That one does not. It doesn't even touch the x-axis. So process of elimination, you know it's going to be this one. Still pertaining to your graphs. This one I know is dealing with square roots because it just looks like a little curve. So let's zoom in to see it. So let me zoom back out so everybody can see what I'm actually putting in the calculator. Alright. So y equal, hit clear. Second, then x squared. Inside or under the radical, put x plus 2. Use your right arrow key. -4. So pay close attention to how you're typing it so that 4 won't be under the radical sign. If so, you're going to have to clear it out and try it again. Make sure you don't forget to hit the right arrow key. Hit enter. We're going to go back to zoom. Go to zoom standard. So let's eliminate our graphs now. Well, we can't use that one because that's above the x-axis. Same thing with this one that's above the x-axis. So now we're left with either this one or this one. Can't do this one because it's in quadrant 4. That has a starting point in quadrant 3, so your correct answer is this one. So if we were going too fast, make sure you pause the videos or either rewind them. We have some more. Are dealing with functions of functions. So these are a little bit complicated because now we're not pertaining to graphs. Now we're pertaining to how to substitute some stuff in. So I'm looking for my paper, paper. And I would conveniently not do this one, huh? And I lied, I did do it. Alright, so this problem is fourfold. You have f plus g, f minus g, f times g, which you can't see. So f times g, and then f divided by g. You have your two functions. So f of x is negative 7x minus 8, and then your g of x is negative 2 plus 9. So warning, this will be one that you will have to look over again. Okay, so let's look at it. So I'm going to be doing quite a bit of zooming in and zooming out. So when we do f plus g, we got negative 7x minus 8 plus negative 2x plus 9. Combine your like terms, so the negative 7 plus negative 2 is negative 9x. Negative 8 plus 9 is positive 1. When we do f minus g, negative 7x minus 8, which is your f of x, that minus sign is going to change everything in g of x now. So we know that two negatives give a positive, and that minus will make that a minus. So we got negative 5x, because that's a positive, negative 7 positive 2, and then negative 8 minus 9 gives us negative 17. Your next one you can't see really, so I'm going to write over it. Hopefully that will help you. So I got negative 2x plus 9 times negative 7x minus 8. It does not matter how I wrote this. I could have written it negative x minus 8 times negative 2x plus 9. Again, it would have been the same thing. So using the form method, negative 2 times 14, I just gave you the answer. Negative 2 times negative 7 is negative 14. Bring over your x's. You got two of them, so add your exponents. Negative 2 times negative 8. Two negatives give you a positive. Bring over your x, so that's positive 16x. For your middle term, we have 9 times negative 7, so that's negative 63x. So I rewrote it like this so it would be easier for us to align everything, aka combine like terms, and then 9 times negative 8 gives you negative 72. Since I wrote it as grouping, bring down your negative 14x squared, because nothing looks like it, plus 16 minus 63 gives us a negative 47. Bring down your x. And since we haven't used it or combined anything with it, that's going to be negative 72. Your last one was f divided by g. So f of x was 7x minus 8 over, because division is just like a fraction, negative 2x plus 9. That's it. Do not try to simplify it or make it anything else. You're just going to divide. So that was your 17. 18, you still have functions of functions, but now they're going to be called substitution is a better way of saying it. So pay close attention to that. So they've given you the answers and the notations. So we got f of g of x and then g of f of x. Here are your answers. Those are your actual functions. So let's figure out how in the world they got these answers. So again, my apologies, I'm zooming in and out quite a bit. So for the first one, you got f of g. So wherever we see an x in f function, we're going to substitute g. So when you see this notation, wherever you see an x in the f function, substitute g. So here's your f function. You got 5x squared minus 4x minus 1. Then you have your g, x plus 2. So notice how wherever I saw an x, I substituted the g value in there. So right here, using the FOIL method, you got x squared plus 8x plus 16. Right here, using distributive function, so 4x minus 16, bring down that 1. Next step, using distributive property, we're going to have 5x squared plus 40x plus 80. Bring down all this on the right hand side, so that'd be negative 4x. Combine the 16 and the 1, that's 17. Now we're going to look for like terms. So we got the 40x and the minus 4. So 40x minus 4x gives you 36x. I'm crossing this out because we just brought it down. We know what happened with the 36 now because that was 40 minus 4. Then we're going to have 80 minus 17 gives you 63. So that was the final answer for that one. So that was f of g of x. Your next one is g of f of x. So wherever you see an x in g, substitute it as f of x. So wherever you see an x in g, you're going to plug in f of x. So I'm going to rewrite it. So f of x itself is x plus 4. So now I'm going to have 5x squared minus 4x minus 1 plus 4. I can simplify some stuff, which would be the minus 1 and the plus 4. So my final answer is 5x squared minus 4x plus 4. Alright, the next 4 problems will require us to read very carefully. So this will be the ideal time for us to actually look at it. So let me zoom this out just enough so you can actually see it. Okay, so for 19, it says y varies directly as the cube of x. Then it says up here, use k as the constant variation. And I cut that off because you can't see it. So I got my equation, which is y equal. I have to have a constant because it says it right here. My constant is k. Then it says the what? Cube of what? X. So x cubed. So there is your answer. Your next one. It says a varies inversely as the square of b. Use k as the constant again. So we got an equation, which is a equal. We know we got to have a k somewhere, so there goes k. Now here's the thing. Inverse means a fraction. So I'm going to have it that inverse of what? The square of b. That's it. So you have to read it carefully. But wait, there's more. For 21, let's read it. And once we read it, we got to figure out what in the world is going on to them. It's also asking for k. So if I wrote it similar to what we did for number 19, so I'm going to have y equals, and then I know I'm going to have a k, because that's your constant. Y varies directly as x. So I don't have to square or cube anything. So I know my y is 52. My x is 2. Or in this case, we're going to say k, because we already know what x is. How would I solve for k? Well, let's divide 52 both sides by 2. So now we know that k equals, what is that? 26. Same thing they got. So remember, multiplication is when it says varies directly. Division is where it's inverse. So let's check this one out. Trying to cut off the next problem. There we go. So y varies inversely as the square of x, where y equals 7 and x equals 4. So y varies inversely. We know we gotta have a constant. as the square of x. Remember, inverse means fraction. So my y is 7. I don't know what my k is. I'm sorry for that. And x is 4. So that'd be 4 squared. We know that 4 squared is 16. So now we have, let me inch it over a little bit so y'all can see that. So now we have 7 equals k over 16. Cross multiply, so 7 times 16 equals k. We know that k is 112, which is what they got right there. So be careful when you read it. Inverse means fraction. Varies directly means multiplication. We're almost done. So your next one, it says determine whether the function is one-to-one. That's going to be a yes or no. Well, one of the ways you can do that, if you graph it, you can actually visualize it. So I'm going to graph it. You can't see me graphing it right now because I'm off the screen. So here's the parabola that I graphed. I know it's not one-to-one because instead of vertical, I'm going to do horizontal. My y's repeat themselves. So notice how right here, I'm going to use my calculator. I'm at positive 4, where I got 2 coordinates at y. So there's a 4. And go over to the quadrant 1, there's a 4. And I'm rounding that up, by the way. So that's why I really didn't want to show you how to do it. But if I'm doing it manually, it's a little bit easier. So here goes your function, x squared plus 1. If I look at it as an equation and try to isolate the variable of x, so now I subtract 1 from both sides, x squared equals 1. X equals both positive or negative 1. Well, that means now I have both positive and negative I. Actually, it's just I. Because remember, we can't have a negative under that radical sign. Well, that's an imaginary number. The other reason why is that it's not one-to-one because you have more than one y value when the y values repeat. You can't have more than one x value because then when you graph it, the y values repeat. So that's 3 reasons of why it is not a function. 24 now. Both 24 and 25, let me zoom in on both of them at the same time if I can. Yeah, great. Notice how you have the exponent of negative 1. Those are called inverses. Well, it's a lot that counts into the inverses, so let's be patient with this one. So let's do 24 first. So one of the first steps that we're going to do, oops, let me zoom out, y'all, I'm sorry. Okay. So the actual function itself is 2x minus 1. To find the inverse, first step is rewrite it in the form of x and y. So y equals 2x minus 2. Second step, interchange your x and y. So mix and match. So again, first step, rewrite the equation instead of it as a function. Rewrite it in forms of y. Second step, interchange your x and y. Now, third step, solve for y. So I'm going to add 6 to both sides right here. Then to isolate my variable of y, I'm going to divide everything by 2. So your final answer is x plus 2 equals y. Still moving along. Number 25. It was also a function. It's a little bit more complicated. So here's what's actually given to you right here. Step 1, I'm going to rewrite the function in terms of y. So now I got y equals x over x plus 5. Step 2, interchange your x and your y's together, so you're going to move them around. This one, because it is a fraction, we got a lot to go on right here. So one of the steps is to eliminate the fraction altogether. So we're going to cross multiply right here and assume that there's an invisible 1 right here. So once we do that, cross multiply, we have xy plus 5x equals y. Well, I want all my variables to be on the same side of the equal sign, so subtract y from both sides. So I'm going to go over here now. Now I have xy minus y plus 5x equals 0. Well, we're still trying to solve for y. So now we're going to isolate the variables of the x. So right here, I'm going to subtract 5x from both sides. Next step, I can factor out a y right here. Notice once I factor, I can divide both sides now by x minus 1. So now I got negative 5x over x minus 1. I do not know why I did that right there. My apologies. But this is one of the problems that you most definitely will have to take time out to go back and review several times. So once again, ladies and gentlemen, thank you for your time and patience. This is kind of a long video, so you will have to watch this in parts. But if you have any questions, please address them during our virtual lecture video when it's time for us to do Module 8. Thank you.